My guest again today is Ralph Ellis.
Yeah, good to be with you again, Tom. We're continuing with the net zero lunacy and how that affects our pocket, basically, because they're spending an awful lot of money on this. So I was going to go through some of the absurd projects that they are trying to achieve net zero. And because I'm in aviation, I used to be an airline captain, I'm going to go with this one, which is the EFAN X aircraft, which sounds wonderful. So this was the EFAN X, and this was a project by Rolls-Royce and Airbus to make a hybrid aircraft. Why? I really don't know, because hybrids simply won't work for aircraft. We will look at why in a minute, but it's just not practical for aircraft. But they got a lot of money for this, so let's look at this. This was the government announcement. Liftoff for electric airplanes, new funding for the green revolution. There's a truism here that if you're going for a grant, if you put green in the grant or renewable or something of that nature, you will get the grant money. And in this case, they got 60 million pounds. So this is not trifling amounts of money. This is your money. This is my money. This is our tax money. And Airbus got the equivalent. I think the total was 120 million euros they got for this little project to make this green aircraft. This is a BA-146 that they were going to turn into a hybrid. And we'll see why hybrids don't work for aircraft. So hybrids will not work because aircraft work at constant power settings. Now, the idea of a hybrid is it really works well in town for a car when you're doing stop starting, and you can use regenerative braking. And, when you come to a traffic light, the engine can turn off and all of that sort of thing. So you're not burning any fuel. That's when a hybrid is working well. But an aircraft will sit in the cruise at the same power setting for hours on end. So there's no gains here to have a hybrid. Aircraft also use very high power settings in the cruise. So it's not as if you could use smaller engines and use the hybrid battery for the takeoff. They did a little bit, but there's very little leeway in doing that because this aircraft, which I used to fly, actually, I used to fly this one, used to work at 98% of its max continuous temperature, EGT, we were using on these things. So we're almost at full power in the cruise. And so there's no way really you can actually make the engines any smaller in the cruise because you need that power in the cruise. So there's no efficiencies to gain there. So you're going to get the same energy consumption. You need the same amount of energy to go from A to B, whatever happens, unless you can make the airframe more efficient or you can make the engines more efficient. And of course, they didn't make the engines any more efficient, as we shall see in a minute. The other problem with hybrids and with battery cars as well is they're very heavy because you've got lots more technology in there to make it all work. Instead of having a direct drive down to your wheels or down to your propeller, you have all of this extra gubbins, which we will look at. Makes it heavier. Weight for a car is a little bit of a problem, with heavy Teslas and so on. You can get away with it, but an aircraft is much more difficult. They're very weight critical because you have to lift that weight. If you can think of a helicopter, before a helicopter can go forward, it has to lift itself up. And it uses an awful lot of power just to lift itself into the air before it can even start moving. So an aircraft is almost like using twice the energy, half to lift it and half to go along. It's not quite that simple, but you get the idea. You need a lot more power for an aircraft. Internal volume limitations. You've got all this extra gubbins and this extra material, this technology could not go on the wing. It's too big. So it had to go in the fuselage. But of course, an aircraft has limitations on the internals. We'll have a look at that later on. Aircraft don't have a lot of extra space. Where do you put all of this technology you're going to use, this hybrid business? And then there's heat constraints. They ended up putting all this equipment in the fuselage. So how do you cool it down? Because all of this technology, all of these pieces of equipment are generating heat. Now, a jet engine, of course, doesn't have that problem. It's sitting on the wing in the airflow, and all of that engine is being cooled all the time. In the fuselage, that becomes a big problem. It was one of the reasons that this aircraft never got airborne. And then it had batteries, of course, and batteries are a problem. The energy density of batteries to fuel is 1 to 40. So batteries will only have 1/40th of the energy density of fuel. But once you take into account the internal combustion engine, whatever you're using, pistons or jet engine, it comes down to about 1/10. So your batteries will have 1/10 the energy density of a fossil fuel powered engine. That means the batteries are heavy. Again, that's not good for aircraft. The location of the end of those batteries, we like to have fuel in the wings because it gives us wing bending relief to have the load in the wings. If you put the load in the fuselage, you've got to have stronger wings, which means the aircraft will be heavier again. And batteries don't burn off weight. When you're flying, you burn off the fuel, which makes the aircraft lighter, which means the undercarriage can be lighter for your landing. You can't do that with batteries. They don't get any lighter as you're going along. So you need heavier undercarriage. Again, it makes the aircraft heavier. And these were big batteries. They wanted a 1.3 megawatt hour battery, which if you calculate that in terms of Tesla batteries for Tesla cars, it's 17 Tesla batteries at 9.5 tons. There's a lot of extra weight. Now, British Aerospace said that they could get it down to 4.5 tons. Not sure how. They were going to use a slightly different technology or packing of the batteries to get it down to 4.5 tons. But anyway, it's still a lot of extra weight. And this is what it looked like. And as you can see, lots of extra gubbins, you might say, all of this material to try and make it work. And all of this material that they got in the fuselage here could only power 2 of these engines, not all 4. So if we were going with the jet engines, the original jet engines that this aircraft had, this is the BA-146. It was one of the best aircraft ever made. I really enjoyed this aircraft. The only drawback slightly on this aircraft was the engines. It had the ALF 507. It's a Lycoming engine, which actually came from it's a tank engine. It came out of the M1, Abrams M1 battle tank from America, which runs on jet engines. Anyway, so they added a fan to it and they made it into an aero engine. You know, why not? So all of these, and it's a geared jet engine as well. It's got a gearbox on the front of it. So all 4 of these engines together weighed 2.5 tons, which is not bad considering, you know, the aircraft for max takeoff on this aircraft is about 40 tons, and only 2.5 tons of that is the weight of the engines. You see how you have to get the weight of everything in an aircraft down to as low as you possibly can. Okay, so what happens when we hybridize this aircraft? Okay, so this is the hybrid. So you've got a jet engine in the back. They would actually need 2 to make this run properly, or 2.5 actually. So you've got a jet engine in the back running through a gearbox because the jet engine is running too fast, into a generator, which is giving you AC. So you have to go through a rectifier to make it into DC, to make it into a battery. There's your 4.5 ton battery sitting in there. Then you need an inverter to turn it back into AC to go down into your electric motor. And these electric motors had a gearbox on them as well. As you can see, there's a lot of extra equipment over and above just having a little engine sitting on a pod, you've got all of this extra material taking up the fuselage. And how on earth do you cool all of this stuff? You've got an air intake here, which goes into the jet engine. And then on the port side here, you can't see it. There was an enormous, great cooling intake to try and get some air in there to cool all of this stuff down. I told them this would not work when it was first announced. I said, it's just impossible. You can't do this. An aircraft will not run with a hybrid. But they had green in the in the grant application, and so they got the money, 120 million euros of your and my tax money to go and make this monstrosity. And they didn't even make it in the hangar. I mean, what you do with this, if someone says we want this project, is you make it in a hangar or in a shipping container or something. You put it in a shipping container and you make it and you see if it works before you try strapping it to an aircraft. But no, they put it into an aircraft. They actually built this thing. And so this was the result. Yeah, it didn't do very well, as I told them it wouldn't. So if it was a jet engine, as we've seen, ALF 507, Lycoming engine weight would be 2.5 tons. Thrust is in pounds for Americans. It's 30,000 pounds of thrust for all four. These are very small engines. They're only 7,000 pounds each, 7 and a bit thousand pounds each. Fuel consumption, nearly 2 tons an hour in metric tons. Fuel capacity, nearly 10 tons. So it's about 4.5 hours endurance. Payload, nearly 10 tons. It'll take about 100 passengers, this aircraft, in its normal configuration. So when you hybridize engine weight, the engines are actually a bit lighter. They were using the Rolls-Royce AE 210, which is actually, it was an Allison engine, you know, Allison jet engines. Well, that was taken over by Rolls-Royce. I presume Rolls-Royce still own Allison. I don't know. And they were using the AE 210, and you would need 2.5 of their engines to equal 4 of the Lycoming engines. So the engine weight is a bit lighter, and pumping out, people don't realize sometimes how much energy an aircraft will use. 2.5 of these engines will pump out 8.5 megawatts. You can power 8,000 homes off that. You can power a whole town from 2.5 of these engines. There is a lot of energy involved in aviation, in getting an aircraft airborne. And this is not a big aircraft. This is only a 40-ton aircraft. It's almost, what's a 737? The 737 will be about 70 tons. So it's about 60% the weight of a 737. So you got generators. The generators had gearboxes in them, so they weren't very light. So they were another 2 tons. Rectifier, 600 kilos. Battery pack, as we saw, 4.5 tons. 1.3 megawatt hours, which is quite big for a battery, as we said, 17 Tesla car batteries, all strapped together. Inverters were 400 kilos. Electric motors, again, they had a gearbox in the electric motor, 880 kilos for 4 of them. They were trying to use the same configuration. So the total engine weight has gone up from 2.5 tons to 10 tons. They've quadrupled the weight of the engine. You cannot do that in an aircraft and hope it will take off, because fuel consumption remains about the same, because the Allison engine is actually more efficient, so it should burn less. But each one of these stages, generator to rectifier to battery to inverter to electric motor, each one of those stages is losing energy. Even if it's 2.5%, 3%, 4% or something, each stage is losing energy. And so overall, you're going to burn the same amount of fuel, because it takes you the same amount of energy to go from A to B, however you're doing it. And this engine configuration is not any more economic. So fuel capacity has to remain the same at nearly 10 tons. So your payload, your amount of passengers you can carry, has to reduce. And it'll come down to about 15 or 20 passengers. And you can see there's no room for passengers. This is the passenger compartment in the front. It's got no room left whatsoever. The whole aircraft is taken up with all of this absurd hybrid technology. For what reason? It makes no sense. Why on earth would you want to do this? Because this is the Allison engine. It was just these are the four Lycoming engines on the 146 aircraft. And this aircraft is almost equivalent. It's a 33-ton aircraft. It uses two of those Rolls-Royce Allison engines. So, one of those engines equates to almost two of the 146 engines. So what was the result of this catastrophe of a grant application? Well, the grant application said that they were going to reduce CO2 by 70%. This was the whole point of doing this. They're going to reduce CO2 and they're going to save the planet. Yeah, people who have seen my previous videos and all of the other videos in your catalog will know that CO2 is the most essential gas in the atmosphere. We don't need to reduce it. But anyway, even if you think CO2 is a problem, the idea was to reduce emissions by 70%, reduce NOx emissions by 90%. But how? How was this going to be achieved? The result, of course, was totally the opposite. We had hugely increased engine weight, a reduction in cabin space, increased CO2 by 600% per passenger. So totally the opposite of what this program was supposed to achieve. And they increased the ticket price for the passengers by 600%. How on earth is that going to help everyone? Who's going to afford a ticket price 6 times more than it was before? And for what reason? You're still pumping out the same amount of CO2 per aircraft, or 600% increase per passenger. How did they get this? That's the big question. What did the grant application say? I mean, this is not Joe Bloggs down at number 22 making an application for government money. This is Rolls-Royce and Airbus. So what did their grant application say? Because I knew this project would not work when it was announced. You can't do hybrid aircraft. So how did they pass this through the system? Because I presume the government has some sort of technical advisors who can look at this and say, is it going to work? Is it worth trying? Is it worth spending all of this money on it? So what did that grant application say? Was it a fraudulent application? Did it have figures in there which were totally impossible? I don't know, because I put in FOIs, Freedom of Information Requests, to BEIS. What does that stand for? Business, Energy, and Industrial Strategy. Anyway, some government department. So I put in FOI requests, and all of my requests were refused. They won't tell us what the grant application said, whether this grant application was simply incompetent or whether it was fraudulent, because they're taking our money and burning our money on a project that had no hope of ever succeeding. I mean, I knew it wouldn't. A child of 6 knew it wouldn't succeed. And of course it didn't. It never got airborne. They couldn't cool it down sufficiently. It was too heavy, too cumbersome. And even though they were only initially trying to change one of the engines into electric, they still could not get it to work. So the whole program was abandoned. And this is the problem with this throwing money at this climate scam, at this net zero scam, because they're just throwing money at it. And so you get these government departments that get money and they don't know what to do with it. Oodles of money. You remember the Biden they put through a new budget, didn't they? It was something like 1.5 trillion for climate mitigation or something, and they called it the Inflation Reduction Act, which must be the most stupid title for a climate scam ever. Anyway, government departments get all of this money, 1.5 trillion. What do you do with it? What do you just splash it around because you've got so much money, you don't know what to do with it. And so it ends up getting spent on stupid things like this and stupid things like this. This is the Electric Aviation Group. I think this is a British company again. And this was their brochure. They were going to make an electric aircraft, a battery aircraft. If you see a brochure with aircraft with solar panels on the top of it, yeah, I can see you smiling there. You know it is a fraud. This is a scam. Because, of course, solar panels can't do anything for an aircraft. So let's look at some of the details a little bit. So I did a calculation for solar panels at 25,000 foot. So we've got an aircraft above most of the atmosphere. Horizontal, so they're not banked into the sun, of course. At most, they'll get 250 watts per square meter. So you got the wing area here is 10 kilowatts. The fuselage is gives you, well, it's 50 square meters, gives you 12 kilowatts. Between the wings and the fuselage, you'll get a total of 0.02 megawatts of power from these solar panels, only at midday, of course, at midday. But this aircraft will need 5 megawatts to keep itself in flight. So you're providing, even at midday at 12 o'clock, 0.4% of the required energy. And of course, these solar panels will do nothing at dawn and nothing at dusk, and certainly will do nothing overnight. You cannot power an aircraft from solar panels. It just simply will not work. So yeah, that's part of the standard. They call this greenwashing. I think most of your viewers are probably quite familiar with greenwashing. This is not for practical purposes. This is just to bamboozle the stupid people we have in government who are in charge of these budgets, who have no idea. They've never been out of an office. They've never done a proper job. They've never been in industry. They've never been in technology. And yet these are the people who decide who gets the money. And so they just splash it around and they see solar panels. Oh, look, that must be green because it's got solar panels on it. No, that's just greenwashing. And what did they say? Targeting a reduction, 100% reduction in CO2, 50% more profitable than other aircraft. Yeah, I'm sure. And noise levels reduced by 65%. So you can operate 24/7 from any airfield you like. Yeah, I put a note here. I saw this in the brochure for the ATP turboprop, again made by British Aerospace. I flew both of those aircraft. And chalk and cheese, the BA-146 was one of the best aircraft ever made. The ATP turboprop, which sort of looked like this, was perhaps the worst ever aircraft ever made. It was called the ATP, which is the advanced turboprop, but it was always known as another technical problem. Yeah, it wasn't the best of aircraft. But anyway, in their brochure, they said because it's got synchro meshing and synchro phasing on the propellers, it would be the quietest aircraft ever. But when it actually came out, it was so noisy. It was like a 747 on takeoff, just sitting on the apron, doing nothing. Yeah, so don't believe the brochures. Yeah, here's another brochure shot. And this is what they were going to do because they found they couldn't do it with batteries. So they were going to do it with hydrogen. And we've all heard of the hydrogen economy. No, that won't work either. So this is what they were going to do. They were going to have cryogenic, so liquid hydrogen stored somewhere. We'll look at that in a minute. Going through these catalytic converters and powering via electricity, of course, the propeller. The only problem is, and my calculations, and I confirmed with Grok and Grok's calculations, is this catalytic converter would have to be 10 times the size we have here. You imagine, this engine is 5 megawatts. 5 megawatts will power a small town. You imagine how big the generating set would have to be to power a small town. It's going to be bigger than this, and you've got to cool it as well. So, you know, a catalytic converter is only at best, it's going to be about 50% efficient, which means like 50% of your energy going through in the system is going to end up as heat. So you've got to cool this down at the same time. Presumably, you're going to use the cryogenic hydrogen to flow through this system to try and cool it down. This is going to be much, much bigger. This is the size of engine pod they're envisaging. You're not going to fit a catalytic converter of 5 megawatts in a pod that size. It's going to be 10 times that size. And that's the trouble with these brochures. It all looks good to these numbskulls in government who are, you know, giving out this grant money because it looks fantastic. Look, you've got an aircraft. This is what it's going to look like. Yeah, but it's not going to work like that. It's impractical. And yet they're just throwing money at these projects. And people are willing, of course, to take that money. I mean, why not? Someone shoving money at you. Company I was working for did the same. You might say, you know, how are people investing in these things? Well, one of the reasons is in Europe and probably in America, I don't know, the government said that all airlines have to have a program to investigate green technology for aviation. So it was mandated by government that they must spend money on these projects. And so what do? They just go around looking for any old project that they can spend this money on in order to tell the government, yes, we've spent some money on green aviation. And so this project was sponsored by CityJet, which is an airline in the UK. That is probably the reason why they were spending this money, because it was mandated. And the company I worked for did the same. This was our aircraft from the company I flew for. Obviously, I didn't own the company. I just flew for them, but this was one of our aircraft, and we gave it to this company, which is called Universal Hydrogen LLC, based in Hawthorne, California, who were going to make a hydrogen-powered aircraft because our company was mandated to go and try and find a solution for green aviation. And so they took this it was an old nail, basically. It was going to be scrapped probably, but, you know, it was given to them as a test bed so they could fit it out as a hydrogen-powered aircraft. And Universal Hydrogen LLC came out with all of these, you know, glossy brochure again. And this was one of the images from it. And this made me laugh. And anyone involved in aviation will probably laugh at this as well. Transcontinental concept. And these blobs in the back, these are the hydrogen tanks, because hydrogen is voluminous. It takes up a lot more volume. As cryogenic is like 5 times the volume of diesel, which is basically what aircraft burn. It's called Jet A1, but it's basically diesel. And they've got all of these tanks in the back of the aircraft. You cannot put fuel tanks in the back of the aircraft. Fuel tanks have to be on the center of gravity, because as you're going along, you burn off all the fuel. If you burnt off all the fuel in these tanks, you would find your aircraft suddenly does a big nosedive and heads into the ground very rapidly. So this is a complete nonsense. And yet this is supposed to be a company that is advising airlines on how to make their aircraft green, and they cannot even get the fuel in the right place. So what do you think happened to Universal Hydrogen LLC, which the company I was working for put all of this money into? Well, this is their website. Yes, they've gone tits up, of course. So, yeah, Universal Hydrogen LLC, founded in 2020 with $20 million. They raised a further $62 million in venture capital. I don't know who are the venture capitalists in 2021, but quite obviously they've gone tits up because they don't have a website anymore. And not surprising. I mean, if you can make diagrams like this, yeah, don't invest your money in companies like this. Most of these, here's a bit of investing advice, because I'm always good at advising people on investments. If it's a green technology, it will not work. It will go bust. So that's my advice on investing. Don't invest anything that has green as in the title, in the brochures, because it will not work. It never has. It never will. And if they were doing this, why didn't they go to NASA? NASA has already done this back in the 1970s. You probably remember we had the oil crisis back in the 1970s, and people were thinking, oh, we don't have any fuel left, because we were getting no fuel out of the Middle East, and prices went through the roof. And so perhaps we need to use hydrogen. So they did this. This was a big paper. It took a long time with a lot of people, a very, very detailed report in how to make a hydrogen 1011. A 1011 is a TriStar. Good aircraft, much better than the Boeings. Everyone loved the TriStar. It was a really good machine. Unfortunately, it lost out to the 747. But there we go. Anyway, they had this big investigation, how to make it hydrogen. And these are the two hydrogen tanks. So at least NASA got them correctly. They got them on the CFG. So you got one in fore and one aft. So the aircraft remains in center of gravity. This was for a cargo aircraft. So your cargo door is here. All the cargo was going to be on the center. And as you can see, these tanks are huge. This is the trouble with hydrogen. It's voluminous. They were going to use cryogenic here, so it was liquid hydrogen. The tanks were going to be 520 cubic meters. That's a lot of area. That's why these are, so big. They're huge. Not very heavy, of course, because hydrogen is light, but very voluminous. Whereas the equivalent diesel or Jet A1 for a TriStar would be 100 cubic meters. So 5 times the volume. So you can't put this in the wing, which is where you would normally put the fuel. A, because the wings aren't big enough, they're not fat enough. B, because it's very difficult to insulate the wings. You've got to keep all of this insulated, otherwise you'll boil off your hydrogen and you'll have no hydrogen left. And then there was lots of problems. Rather than going this electric route, which I can't see this being the best idea, with catalytic converters and then electric motors and God knows what, they said, well, we'll just put the hydrogen through a standard jet engine. It's an established technology. However, the investigation showed that you would have to change the engines almost a complete redesign. So the jet engine will remain the same. So if you've got a 3-spool jet engine, that would remain the same. But everything to do with the fuel pumping, the fuel distribution, the type of blades you're going to use and the cooling of the blades, and the combustors especially, all of that will have to change. So the engines will be radically different, but it is still established technology. And you can fit it in. You don't have all of this problem with, the hybrid engine and the catalytic converters and so on, everything we've looked at. It's just a standard jet engine. I think that's probably the best way to go. anyway, NASA said that this was feasible, but it does mean a redesign of the airframe and a redesign of the engines. And of course, a redesign of all the ground equipment to service the aircraft, to refuel it and everything else. So is virtually a new industry. You would have to replace everything. That makes it very expensive. So it can be done, but there are problems. Here's an example of where it can be done. JCB is the big digger manufacturer in the UK, very successful company. And they were tasked, like everybody else, you've got to go green. You know, all of the cars, last year it was mandated that I think 21% of all cars sold in the UK had to be EVs. Next year, it goes up to 25% or something have to be EVs. So everything is being mandated that you must do this. And of course, JCB were mandated that they must do something about their diggers. But they knew that they could not make them with batteries because the batteries are too heavy and they don't have enough power, enough energy. So they said, well, why don't we use hydrogen? And so this is their hydrogen-powered backhoe digger, and there's a standard digger at the back there, all with hydrogen. And how did they do that? Well, they just put it through a standard engine. So this is a standard JCB diesel engine. They make their own engines at JCB. And what they've done is they've changed the top end to burn hydrogen. So obviously they've put a different induction system, and they've obviously got an ignition system in there as well now, obviously, to burn hydrogen. And it's a very successful engine. It works very well on hydrogen. And hydrogen, of course, is very clean burning. So these engines will last a long time. So, there's no contaminants to get into the oil like you do with a diesel engine. So these engines will actually last a long time. So it's all a good idea. And this is the truck they use to refuel your hydrogen diggers when you're out on site. And they've got the hydrogen tanks in the back here. The only thing I'm uncertain with this, because they're saying, oh, this all works, this can go into production, in a year or two time. The only thing I'm not certain about is the size of the tanks, because every time I see them demonstrating this, this is the fuel tanks here for this digger. Let's have a look on, oh, I didn't mean to do that. Let's have a look. Yeah, so this black box here on the right side of this backhoe is the fuel tanks. And the fuel tanks look like fire extinguishers, basically. They're cylindrical, which you need to do. They're using gaseous hydrogen, not cryogenic, but gaseous. Is the size of them, because hydrogen is voluminous. And in all of my calculations, and I confirmed this with Grok as well, Grok agreed with me that gaseous hydrogen needs a tank that is 10 times the size. So the standard tank, diesel tank for this digger, because it's not a very big digger, this has 160 liters, which I think is in US gallons, it's about 40 gallons, something like that, for diesel. So you would need a tank of 1,600 liters, or 400 liters 400 in gallons volume. So I don't agree with their tankage. I don't think their tankage will give you the same amount of usability of your digger as the old diesel ones did. So that needs confirming. If anyone wants to buy a hydrogen powered digger, is to confirm how much runtime you get from those tanks. That is my only consideration. But other than that, this works. Oh, the other consideration, of course, is the hydrogen cycle is highly inefficient, which is going to put up your fuel costs. So between wind turbine which I presume is where they're going to get the energy, through electrolyzer, through compressing or cooling, whatever you're going to do with the hydrogen, and then putting it back through the JCB engine, you lose 75% of the energy. So it's not very efficient, and that will make the hydrogen as a fuel source much more expensive than the diesel. So that is another drawback. So that's something that needs to be investigated. If you're buying a vehicle like this, how much is my hydrogen going to cost? Because it might be a lot more expensive. I think the way to go is this way. So forget all the hybrids, forget all the hydrogen, forget all of the batteries. This is the way to go, in my view. And this is regen fuels, which is a word that I made up because I didn't want to call it SAF fuels. People have been calling this synthetic fuel, but synthetic fuel can be confused with biofuels and whatever. This is regen fuels, which is regenerative fuels, fuels that can remake themselves. And this is by a company called OXQ. What a stupid name that is. Anyway, it's Oxford University, chemical department in Oxford University. And they've made this new way of cracking and making standard diesel or aviation fuel. And it goes in a circle. That's why their logo is a circle. So you burn the fuel. That's why it's like steamy over here, which puts CO2 back in the atmosphere. And then you take that CO2 and you crack it and you turn it back into fuel again. So it's regenerating the same fuel that you've just used. And so this is what you do. So you take CO2 from the atmosphere, you combine it with hydrogen, which comes from water. Of course, you split the water, you get your hydrogen, and you put it over this catalyst, and you get long chain carbons. You can make your own fuel. The only thing that's not on here, which you will need, is a ruddy great nuclear power station to power it. Because, of course, you've got to put the energy into this system in order to use it as a fuel. But it's carbon neutral. If you're one of those retards that thinks that, carbon is a problem, I don't, you don't, we don't. But, if you're Ed Miliband, who's our energy minister in the UK, and he's a zealot, he really is that guy. If you think CO2 is a problem, this is CO2 neutral. So instead of all of these projects that we've been seeing, people throwing money at left, right, and center, why don't they put some money into this? Because this poor little group have been struggling along on, a few pennies here and a few pennies there, not really getting anywhere because the government won't put any money into this project. Just like the government will not put any money into thorium fuel. Forget uranium as a fuel for nuclear power stations. We should be using thorium. But Britain is not, and America is not, funding thorium research. And that is obviously the way to go in my view, because there is an awful lot more thorium in the world than there is uranium. Anyway, that's another topic for another day. I'm sure that there is a guy that does very good talks on thorium. You must get in touch with him maybe, because it will be a very interesting talk on how we should be using thorium reactors. Anyway, topic for another day. This is the regen production unit. So it's not actually very complex. This is obviously just a laboratory size. This only makes, I think, about 1 gallon a day. So this needs to be scaled up to industrial size. But the advantages of this fuel is it's plug-in fuel. So it's exactly the same as the standard aviation fuel or diesel that you're using at present. It can run through the same pipes, the same tanks, the same engines. Nothing has to be changed. In terms of aviation fuel, obviously airports don't receive their fuel in tankers. That's not how we run airports. So airports are all piped from refineries. This fuel can run through the same pipes straight to the airport. Synthetic fuels, biofuels are not allowed to go in the same pipage. But this is a plug-in fuel. Nothing needs to change. Same tankage, same pipes, same engines. Everything remains the same. All of your petrol stations will remain exactly the same. You're just using I don't like to use the word synthetic fuel. It's a regen fuel. It's a regenerated fuel. And this fuel is cleaner burning. Because when you're burning fuel, you're supposed to have long chain molecules, but a lot of these hydrocarbons are actually ring molecules, and they call these aromatics. And it's the aromatics that cause all of the carbon deposition you get in diesel and aviation fuel. Now, in aviation fuel, I think they cut the aromatics down to about 20%. But in diesel, you can have, 40, 45% aromatics, which is why diesel has, all of this black soot coming out of the back of it. Well, if you're making your own fuel, you can make it, you can specify it through your process to have no aromatics. So it's a much cleaner burning fuel. So everything will be much cleaner using this particular fuel. And it's CO2 neutral, as we've discussed, if you make it with nuclear power stations. So that's the way I think we should be going. We should be using regen fuels or R fuels and not hydrogen, and certainly not hybrid engines. So that's most of my talk. But since we were talking about aircraft, and since I inhabit the internet and X, of course, you can't go anywhere nowadays without some people talking about chemtrails. This is the scandal of the century. We're coating the skies with chemicals which are being poured out of the back of all of these aircraft, flying across the sky. And people believe this, and I think it's something that needs to be squashed because it's total nonsense, and we shall see why. So this is a 737. This is a 800 series by the looks of it, with that engine on the front. And I used to fly this aircraft, I've got 10,000 hours, I think, in these particular aircraft. So I know a little bit about these aircraft. So this is from professional experience. And what they're saying is there is secret tanks in these aircraft and secret spray equipment on the back of the wing with which, all of us pilots and aviators, we're spraying the skies with all sorts of unknown chemicals to, I don't know, change the weather, kill people or something. I'm not entirely sure what this chemtrailing is for. It's probably for weather control or something of that nature. But where do you put the tankage? Okay, so you've got passenger compartment on the top, and below you've got holds. You've got aft hold and lower hold. So this is the aft hold. Most people will not have seen underneath the aircraft. This is the lower hold on a 737. It's not very big. You can't stand up in there, of course. These are standard suitcases. You can only crawl up there. It's not a very big aircraft, the 737. If you're in a sort of like a 787, you can stand up and walk in the rear hold. But anyway, this is the rear hold. It goes from the back of the aircraft up to the wheel well bay here. There is no room for extra tankage. This is the front hold. It goes from the electronics bay at the front of the aircraft to the wheel well bay, and it's all baggage. Again, there is no extra tankage available. This is the back of the wing. This is a big space here for the flaps. When the flaps go up, they go into this space here. There is no extra room for tankage. This is the wheel well bay, and this is one of a kind. We don't do this in aviation. This is the wheel well bay, which goes up into the hydraulics bay and the flight control bay. Not a good idea, because if your wheel is thrashing bits of rubber around, it's going to destroy all of your hydraulics and your flight controls. This is the flight control mixer box here. These are all hydraulics tanks. These are the fire suppression tanks at the end. Is that side? No, they're the other side. We'll see those in a minute. Yeah, it's not a good idea to have your wheels coming up into the hydraulics bay. All other aircraft have a separate bay, of course, for the hydraulics. This is looking the other way, and you can see the big round hole where the wheel goes up into there, into the hydraulics bay. There is no extra room here for extra tankage. This is the wing tanks. These are the fuel tanks. So the whole wing is a fuel tank. So this is the top skin of the wing. This is the bottom skin of the wing, and it's full of fuel from top to bottom. Obviously, they've drained the fuel out because we've got a person here changing a pipe. These are the fuel pipes. This is one of the fuel pumps to pump fuel to the engines. So he's working on that. There's a hatch here. You can see he's climbed in through a hatch, and he's working on this fuel pipe. So this is all fuel from the wing root to the tip is one big tank. And then in the center of the aircraft, there's the center tank, which runs through the center of the aircraft. And again, it's all fuel. There's no extra room for extra tanks. There is nowhere on this aircraft for extra tankage for spraying anything. And everything you put into an aircraft has to be on the load and balance sheet, or they call it here load and trim sheet. Every single thing from every passenger, every piece of baggage, every piece of hand baggage, every kilo of fuel, every kilo of oil, every kilo of water, you know, because obviously we have water on board for coffee, for the toilets, you know, all of that has to be on this sheet somewhere. So this is the weight of everything. This is the position of everything, because you need to balance the aircraft, of course, so you need to do the balance as well. You cannot have extra tankage that nobody knows about secretly stashed away somewhere on an aircraft without it being on a load and trim sheet. If anyone was doing such a thing, A, they would be banned from aviation immediately. B, they would be endangering their passengers because the aircraft might be overweight or it might be out of trim and therefore go out of control. You cannot have extra weight just appearing somewhere in an aircraft that nobody knows about. Remember, these aircraft are inspected by tens of people on every turnaround. You think of how many people visit the aircraft. You've got the captain and first officer. You've probably got 2 engineers. You've got a load master and the guys he's in charge with down to doing the loading. You've got the ground operations guy who's walking around the aircraft as well. You've got the guy who does the honey cart, and all of these people come to and the refuelers, of course, come to the aircraft and inspect the aircraft. Every aircraft is inspected before every flight. Every aircraft is inspected every day by an engineer, and they will be by different engineers, because every time you go to a different airport, it'll be a different engineer, different crews, everybody inspecting hundreds of people will inspect an aircraft every day. And yet none of those hundreds of people have ever noticed some extra tanks or spray equipment on the back of this aircraft. Yeah, no, that's not going to happen. I can assure people that no commercial aircraft has extra tankage or extra spray equipment. And this comes about, this conspiracy comes about because there's an awful lot of people who are unworldly. They have never been out in these industries. They've probably never been in any technical industry ever in their lives or done any engineering of that nature. You know, they're probably all sitting in their back bedroom or working in an office or something. And they don't, oh, yes, who's that? Oh, that's me. This is part of the conspiracy. That's why I added this image on, because they say they're a white-tail aircraft flying around. They've got no logos. They've got nothing on them. Well, yeah, I used to fly them. This is a white-tail. The reason we fly white-tails is because this is a freighting aircraft. You can see the freight door here. And freight door aircraft have no passengers. So they've got nobody to advertise to. We only fly at night normally. So nobody can see us. So who cares if we have a logo? Um, so the aircraft, and you can see it's got no windows either. The aircraft is just painted white because it's cheaper. That's why we fly whitetails. Anyway, this is me. I was a captain on these aircraft for 20 years, and I was a captain on 146, another aircraft, for 20 years before that. So, yeah, 20,000 flying hours, which is not bad for, a career. I'm retired now, so I don't have to worry anymore. Anyway, 20,000 flight hours by the time I retired. And so people don't understand clouds. Here's clouds. Why do clouds happen? Well, it's all to do with the humidity in the air. This is a tephigram. Met people will know that about this. We don't have to worry about this so much in aviation because the Met man translates it for us. But if you're in gliding, glider pilots like to look at these things because it tells you how strong the thermals will be. And this is a tephigram going up through the atmosphere between temperature and dew point. And from this, you can see if you're going to have a cloudy day or a clear day. That's the idea. And if you've got a wide space between these two lines, then there is going to be no clouds. And there will be no contrails either. Where they meet, that's fog or clouds, as it. So at the bottom here, this is sea level down the bottom, 1,000 millibars. Where they meet down the bottom, this is early morning fog because the dew point and temperature have met. Then there's nothing in this atmosphere all the way up to 500 millibars. Yeah, we work millibars. In America, they work inches of mercury, just to be different. But anyway, we work millibars. 500 millibars is half the atmosphere, which is 18,000 foot. And then it goes all the way up to 300 millibars, which is 30,000 foot. So that's easy to remember. So in this tephigram, you've got no clouds all the way up until about 25,000 foot. And then you might get some clouds because the temperature and dew point are fairly close together here. So you might get some clouds and some contrails up the top. And nothing down below. So the contrailing band is often quite small. It can be 5,000 foot. So you're not going to get contrails all over the place. You will only get contrails in a certain band of air, depending on the humidity of the air. So these are some of the clouds we get. People look at these and they say, oh, that's man-made. Look at that. That's strange. It looks odd. It looks like a UFO. No, this is just a wave cloud. So when wind goes over a mountain, it will start waving. And when the air is going up, it's cooling and it will condensate and it'll form a cloud. And so you get these stationary clouds just sitting there looking very odd. But this is perfectly natural. This is a wave cloud. This is Mama. This is indicative of a thunderstorm. So this is downwelling air in this thunderstorm colliding with upwelling air as a part of the sun. So if you see this, you will have a big thunderstorm close by. It's quite dramatic when you see it. Normally, you'll only see this in tropical regions. I've never seen this in Britain, but because we don't have thunderstorms that are big enough. Here's some more mamma. It looks very odd. It's mamma meaning breasts, so you got lots of little breasts. This is mare tails. So this is a high strata Q. Probably ice particles, not water. And the atmosphere has different bands with different winds traveling in different directions and different speeds. So this is ice particles dropping down into a faster airflow down below it, and that's whisking the clouds along and forming these mare tails. And this is quite a common formation. You'll get this quite often. Here's another mare's tail. This is a roll cloud. These are unusual. This is a sea breeze type effect. You'll only find this really in coastal conditions. And this is where you get a change between night and day, and you get sea breeze to land breeze changes. And this is a rolling of the air as the two air masses meet, and it goes round and round and round, and forms this big, long roll cloud like this, sometimes called a soliton. But you've got two here, or even three, so it's a duotton instead of a soliton. Very unusual. Again, normally tropical. So you'll see this in Australia, perhaps Florida, maybe. I've never seen one in Britain. They're fairly unusual. People think these are man-made because how can nature do that? But nature will do this. It's a sea breeze effect. These, again, people say, how can this happen naturally? This happens naturally. Clouds will follow each other for two reasons. They either street, which is going with the wind, and because of the convective process, they will form into long lines occasionally. Or this is wave coming off a mountain range or a hill range, and the air goes up over a hill and then it drops down and it starts waving. Just as waves on a sea or waves in a river, the air will do exactly the same. And where the air is coming up, when it's going up, it's cooling and it'll form clouds at the top of the waves. So just maybe as you might see, white crests on the top of waves at sea, well, here's the white crests on the top of the waves in this stratocumulus. Here's another type of wave. This might be a slightly different waving pattern. When you get two blocks of air at different altitudes traveling in different directions, which you do get, the wind is not all going in the same direction. You will get different wind speeds at different altitudes and sometimes different directions with different altitudes. Where two air masses meet and touch each other, they can form these wave patterns. And again, where the air is going up, it's cooling and therefore it's condensating. Sometimes it can be blue, of course, because if the air is not humid enough, it's not going to form any cloud. It has to be humid enough to form the clouds. This is just interesting, but this is just a rainbow effect, basically. This is the cloud with the sun refracting through the cloud and producing a colored effect, but it's just like a rainbow, nothing strange. These are interesting. This is called diamond dust. So if you go up into the far north, Canada or Scandinavia or something where it's really cold, really dry air can have little particles of ice. And these are not round particles like you might think with mist. These are little shards of ice, and they're microscopic. Sometimes you can see them settling out on your gloves as little tiny shards of ice. And that's why it's called diamond dust, because that's what it looks like. It looks like little diamonds. And they're so light and so small that they can just hang in the air. And you can't really even see them unless you're looking at the sun and suddenly you get these rainbow effects coming up from the sun. So it's just refraction of the sunlight, and it can look quite spectacular like this. I've only seen this once when I was in Russia, but you often see it in an airliner if you're up at 35,000 foot because it's so cold up there. Again, sometimes if you get the right conditions, you can get diamond dust at high altitude. And that's just refraction of the sunlight. So how do we get contrails? We were talking about contrails and chemtrails. Well, the byproduct, the emissions from engines is CO2, so carbon dioxide, carbon monoxide, and water. Now, it's hot when it comes out of the engine. When it cools, going into cool air, it can condensate. It doesn't always condensate because it depends on the humidity, of course. You know that with your own car. You'll only in certain conditions will your car give a condensation plume at the back of it. It has to be humid. And then we get contrails, condensation trails. And these are what some people are saying are chemtrails. It has to be deliberate, that they last a long time. And sometimes they don't last a long time. So therefore, sometimes they're spraying and sometimes they're not spraying. No, again, that depends on the humidity. If you have high humidity in the high atmosphere, then the contrails will last for a long time and they will start to spread out as this one has. If it's very dry in the atmosphere, you will get the shortest ever little contrail that you can hardly see behind the aircraft, and all of that water will dissipate immediately. So it depends on the humidity as to how big these contrails get. Let's increase the size. And there we get lots of aircraft following each other. Obviously, there are lots of aircraft running on airways, and so you get multiple contrails. Do these affect the climate? Well, yes, they do, actually. So you can say we're geoengineering in a way. During the day, contrails will reflect away the light, and they are a cooling effect. Now, during the night, they act more as an insulator, preventing the upwelling long-wave radiation from escaping. And so they are a warming effect at night. And the balance between the two is that contrails are a slight warming effect during the whole day, between day and then night. Here's some more spreading out. Here's ones that people say, well, this has got to be man-made. Look, they're spraying because they're doing a grid pattern. Look, this is deliberate. No, this is the wind. This again is where people are not very worldly and they don't know how things work, how the atmosphere works, how aircraft work. Well, what's happening here is you've got two airways. So here it is diagrammatically. You've got one airway here with an aircraft on it, and one aircraft, another airway here intersecting with another aircraft on it. And you've got the wind pushing down. Now, if this aircraft makes a contrail here, the wind will push this contrail down and down again and down again. But remember, there's another aircraft following on behind, 10 minutes later, 5 minutes later, and its contrail would be pushed down and down and down. And same from this airway as well. Its contrails would be pushed down and down and down. And so with all of these contrails coming back down from these two airways, you end up with this grid pattern, because this was the first aircraft here making this contrail. And then the second aircraft made this one. And then the third aircraft made this one. And then the fourth aircraft made this one. So you've got four aircraft have been down this airway, and the wind is just pushing all of these contrails downwind. And you get this pattern. You can see a fresh contrail here, a slightly older one here, an even older one over here. And this one is almost dissipating. So it's just the wind pushing these contrails around. There's nothing strange about this. And again, no commercial airliner has any spray equipment on it. I can guarantee you that for 40 years of working in aviation, there is no such thing as a commercial airliner that has spray equipment on it. This is just another interesting one. Obviously, this is a contrail. It's funny colors because this is a rainbow, basically. So you got the sun refracting through the contrail. Nothing strange about that. Here's a 747 looking down from another aircraft above, and you can see the contrails coming out of the back of the engines and then folding over on top of each other because there is a big vortex on the top of this aircraft. That's how aircraft fly. The high pressure air comes up underneath the wings and forms a big vortex, and it folds. These two contrails get folded into one, and that's just how they look. If you see a four-engine aircraft going past you, that's how it looks. Here's an interesting one. People get confused by this. Why is this aircraft spraying from its wings? No, it's not spraying. This is a 757. The 757 was well known for having flap vortices. Not many aircraft do, but 757 used it all the time. So this is coming into land, obviously. It's got its gear down. You can see the flaps are down here at the back of the wing. And on the tips of the flaps, it forms a vortex, a circular motion. And these vortices, if they can persist for a long time. Anyone who's blown a smoke ring will know that these smoke rings can persist for quite some time. And that's what we're getting here. Although it's not a smoke ring, it's just a condensation ring. So a vortex is a spinning tube of air. In the center of the vortex will be lower pressure. Lower pressure means you're cooling the air. Cooling the air means it will condensate. And that's why you get this contrail coming off the back of a 757. And these contrails can be quite persistent. You can see this one going down and falling behind the aircraft. At Manchester, which can be quite humid at Manchester, we used to see these contrails from the flap system spiraling down and hitting the ground and then running around and wriggling around the ground like a big snake, because vortices can maintain themselves for quite some time. They're quite funny things, vortices. This is an odd thing. People will say, no airliner will do this. What's this all about? Well, yeah, this is standard for an airliner. What this is a holding pattern. So a holding pattern is an oval shape that an aircraft will fly when waiting to go into an airport, something like Heathrow. And you go round and round in these big ovals. However, the wind has taken these ovals and pushed them downwind. So it's one aircraft going around in one oval pattern, and then the wind has pushed the contrails downwind. And so this aircraft has gone round this holding pattern 1, 2, 3, 4, 5 times round a holding pattern. And a holding pattern is 4 minutes. A standard holding pattern is 4 minutes. So this aircraft has been sitting there for 20 minutes in this holding pattern, and the wind is pushing the contrails downwind. Here's a nice shot. This is DC-10. Not quite as good as the TriStar apparently, but anyway, DC-10, fairly successful aircraft coming into land, and the whole of the top of the wing is obscured because the top of the wing is under lower pressure. Lower pressure means lower temperature, means you get condensation. And again, you've got flap track vortices coming off the back of it. Actually, this is an MD-11. The DC-10 was uprated into an MD-11, and it's got the winglets on the end of it. So that's why this is all condensation again. Nothing strange here. This is interesting. This is a Russian bear, and it's created this big hole in this cloud layer here. Why is that? Well, because the back of an aircraft has descending air coming off the back of an aircraft. That's how an aircraft stays up. One way of thinking of how an aircraft stays up is action and reaction. That when an aircraft moves along, it's forcing air to go downwards, which is an action, and the reaction is you get lift. So the back of an aircraft always has to have descending air coming out the back of it. And that descending air, because it's descending, is warming. That's what they call it adiabatic warming. Any air that's going down, increasing its pressure, is warming adiabatically. And therefore, it will not have any clouds. The clouds will dissipate. And that's what's happening here. The clouds are dissipating because the air is going down behind this aircraft. Again, that's just perfectly normal. Concorde only managed to fly at low speeds because they generated a vortex on the top of it. So the wing was designed to generate this vortex on the top because Concorde had no flaps, but it had to go from Mach 2 down to landing speeds. How do you do that big, vast change in speed between Mach 2 and landing speed? Well, they made this wing specially make a vortex when it came into land, and that vortex helped it generate lift. It's not very efficient. You don't really want to do this on an aircraft. It's not an efficient way of flying, but it gives you extra lift for the takeoff and the landing, and that's why it's generating this cloud on the top of the wing, because there is a vortex sitting there. Now this is chemtrailing. So chemtrailing does exist, but as you see, this is a very special type of chemtrailing. This is cloud seeding. So you'll see it's a light aircraft. It's not a commercial aircraft. And this is a very specific cloud seeding to produce rain for farmers, mostly in America, mostly sort of California type way, maybe in the south of North America. And farmers will pay people to go and seed clouds to make them rain. Now, this is a very special type of chemtrailing, if you like, because you must have a cloud there to seed. You cannot do this in blue sky and expect rain to suddenly pour out of the sky. That's not how it works. You need to have a cloud that is ready to maybe turn into rain. And you must seed that cloud. They use various salts, silver, and I think you can even use table salt if you can, grind it up fine enough. You just need a nucleus for the water to actually adhere to and form raindrops. Quite controversial, because if you are paying them to seed clouds to pour rain on your farm, you're probably taking rain away from a farm that's just downwind who wanted that rain as well. And they don't get any rain because you've nicked it all. So this is fairly controversial, but it does happen. They go up and they seed clouds to make it rain in a particular location. They do this in the Middle East as well, because obviously they're very rain deficient there, and they want to try and get as much rain as they can from any clouds. So they don't want to let these clouds disappear and zoom over somewhere else. And so they will try and seed these clouds to get as much rain out of them as possible. But this is not chemtrailing. This is not high-flying commercial aircraft. This is a special small aircraft. Okay, this is a pressurized aircraft, but I doubt if this aircraft will ever go much more than 15, 20,000 foot to seed these clouds, because you don't need to go to the top of the cloud to seed it. All you need to do is put the agent, these are almost like fireworks basically that go off at the back. You need to put this agent into the upwelling air that's going up through the cloud. And you can do that almost at any altitude. You could do that at 5,000 foot or 10,000 foot. And the cloud itself will suck this material up into the cumulus cloud, and hopefully you get some rain out of it. But this is fairly rare. There's not many places that will do this. I don't know anyone in Britain who would do this. Why would you want to do this in Britain? It rains here all the time anyway. There's absolutely no point doing this. So if you're seeing contrails over Europe and Britain, it's got nothing to do with this. What else have we got? Oh yes, did you know they were chemtrailing back in World War II? So yeah, the U.S. Air Force took time off from bombing Japan to go chemtrailing because that was so important during World War II. No, this is standard contrailing, even from piston engines, of course, because they're using the same fuel. This was the first time that people really noticed this, because this was the first time that we got aircraft to go high enough into the contrailing regions, because normally contrailing, you'd only get it above 25,000 foot, really. And this was the first time that these large aircraft got high enough to actually see that they were contrailing. And especially in humid places like in the tropics down in the Pacific campaign, they would be contrailing quite often. And of course, the pilots hated this because it's pointing out your location. And everyone can see you from miles away. So they would try and stay out of the contrailing regions if they possibly could. They wouldn't want to stay in this sort of conditions like this. Here's another interesting one. This is, I don't know what this aircraft this is. It's another 4-engine aircraft, World War II. And you can see the upper level. Obviously, there were bands of aircraft were all going out at different levels so they don't collide with each other. The upper band is contrailing. The lower band are not, because they're not in the contrailing region. So the contrailing region, again, is quite a small band. Sometimes it's only about 5,000 foot deep. And so you can actually drop out of it if you want to. And this is an interesting one. These look like Liberators to me, these. Anyway, again, they must be taking off in a very humid condition because we're getting prop wash. So we're getting tip vortices from the propellers are forming contrails as well. That's why you get these circular coils of contrails coming off the tip props, or prop tips, should I say. Again, this must be a very humid location down in the tropics somewhere. Like this is on a carrier, so now no doubt this is out in the Pacific somewhere. This is a Bearcat, I think, this one. And you can see the tip vortices are causing this helix going around the aircraft because it's so moist, so humid. Here's another one. This is a Corsair. And again, you get this lovely helix coming out, another carrier operation out in the Pacific, no doubt. And it still happens today if you're in humid conditions, and you can see these tip vortices going round around the aircraft. All perfectly normal. And, oh, this is the last one. So we're nearly at the end here. This was highlighted as being proof that aircraft can contrail. And this was someone contrailing on the ground to test out the system. No. This is the APU at the back of the aircraft. So all of these large commercial aircraft will have an APU, which is an auxiliary power unit, which is a small jet engine in the back of the aircraft. And if you have a wet start or a hot start, it will pour smoke out of the back of the aircraft, basically. This is just fumes from diesel. Aircraft run on basically on diesel. It's a highly refined diesel, basically, which is called Jet A1 or AVTA. And this is what you get. This is, the same as you would get out of a diesel truck if it wasn't burning cleanly. So this is just smoke from the APU, nothing to do with chemtrailing. So yeah, that's the end of this little show. So in summary, no commercial aircraft has any chemtrailing equipment on it. There is no such thing as chemtrailing from commercial aircraft. It simply does not exist. So I hope that explains something to the people who are continuously maintaining this conspiracy theory.
I think there's a terminology question here about, so like I asked Grok, did the U.S. use weather modification in the Vietnam War? And Grok says, U.S. Air Force flew over 2,600 sorties, dispersing silver iodide and dry ice into the clouds, and reportedly extended the monsoon season by 30 to 45 days. So you make a strong case that commercial airlines are not doing this, commercial airliners, but other planes may still be doing this, right? Or are you confident that nobody is trying to do any sort of weather modification now?
Well, that silver iodide is the same as that small aircraft we saw with the fireworks on the back of it. That will work, but it will only work if you've got the right type of clouds in the region that you're going to seed. So if you see aircraft contrailing in blue skies, that is doing nothing, even if they were dropping silver iodide, because there are no clouds to seed. You cannot get a cloud out of blue sky. So that would only work if there were, proto thunderstorms in the area, and you went around and seeded them and got them to drop their water earlier than they would have done, which is what they try to do sometimes in Saudi Arabia, because they want the water, and so they capture it before it goes to Iraq, and then Iraq gets annoyed because they've got no rain because they've already stolen it. So, I mean, that does work, but it's not used in many locations because not many people need extra rain, to be honest. Perhaps in, south of North America, of course, you might want to seed some clouds there, Saudi Arabia, various places. But it's expensive for what results. You get a bit more rain if you need it. And it wouldn't look like the standard contrailing that people are complaining about. It would not look like that. It would be aircraft flying in cloud, so you probably wouldn't see the aircraft anyway, dropping, as you say, silver iodide or something of that nature as a nucleotide to attract the water onto these droplets. I very much doubt if anyone is doing that on a big commercial scale. It will have no commercial purpose, really.
Yeah, this is fresh in my mind because I just interviewed Matt Landman, who did the movie Frankenskies, and he's doing Frankenskies 2. He's talking about all the different patents for weather modification, and it could potentially be tried using private planes or drones or balloons or rockets or even some sort of a HARP thing to try to heat up parts of the atmosphere, maybe. But how about the whole issue, though, of geoengineering and of Bill Gates types thinking we need to cool the Earth and we need to experiment with blocking out the sun? There's all sorts of open talk about doing that. Do you have any opinion on that?
In a sense, that could work. I'm not sure it's I don't think it's a very good idea. I think they were going to put sulfur dioxide up. We've actually done that experiment because ships were the biggest emitters of sulfur dioxide. It was ships and electrical generators, power stations. So power stations were putting out a lot of sulfur dioxide, and ships were using that horrible tar they used to use as a fuel. It's awful, dirty stuff. And ships were putting out like 25% of the SO2, and the rest was put out by power stations. So we've had that experiment already, and there is some evidence that was a bit of a cooling effect from all of that SO2 that we were putting in the atmosphere. Now, power stations were mandated not to do that back in the 90s, I think it was. So they stopped doing it then, mainly because of the acid rain scare and things of that nature. And then ships were mandated not to do that in about 2020. And so all of that has been taken out of the atmosphere. And I did see some papers that were saying that global dimming has stopped. So as a part of Met surveillance, they have these monitors for monitoring the amount of sunlight that hits the ground. And since like 1970, the amount of sunlight was reducing. It was known as global dimming. We were getting less and less sunlight from the sun. And they were saying it was because of this SO2 that was going into the atmosphere. And now, of course, the amount of sunshine we've got is actually increasing again. And of course, they were saying that this is because SO2 has been eliminated from power stations and shipping. Now, that might be true, but I think the total effect on the climate in terms of temperature was not that great, even though they could measure it in terms of the amount of sunlight. Because remember that the Earth has a thermostat. They call it the thunderstorm thermostat. And if you put a lot more energy in, say, for instance, the sun suddenly burst into life and gave you 5% more sunlight for some strange reason, well, the Earth would cool itself down because it would produce more thunderstorms. And those thunderstorms can extract a lot of that energy and take it back into the upper atmosphere and re-emit it back into space again. And this is called the thunderstorm thermostat, which keeps our temperature fairly constant, no matter what's happening. For instance, if we got lots of volcanoes and things of this nature, we still retain a fairly static total temperature. So I'm not entirely, well, I don't think it's a good idea that Bill Gates is trying to promote this, and I don't think it will actually work.
Okay, and just checking here, what you just mentioned with the thunderstorms, that is Lindzen's iris effect?
I read a paper also. Yeah, there's a few people done papers on this. I read one by Eschenbach. What's his first name? I can't remember. Anyway,
Willis.
anyone who...
Willis, right? Isn't it Willis?
That's right, Willis Eschenbach. Anyone who inhabits What's Up With That will know Eschenbach. And he wrote a paper which he never actually got fully peer reviewed, which I think was a shame because it was quite a good paper. And it was actually entitled the Thunderstorm Feedback or something of that nature. Anyway, so yes, it's a real event. This actually does work. It's part of the climate system.
All right. One other question is, I think I may have asked you this when we had lunch back in London a while back about the fuel that's used in commercial jetliners now. You think is cleaner than it was in 1970, and are people testing that to make sure that there's no change since 1970 because of maybe they're using green fuel and it's not burning as clean? I've heard people with that hypothesis.
I don't know if it's cleaner than it was in the 70s. It's cleaner than diesel, so diesel is fairly dirty. Aviation fuel, Avter Jet A1, is much more refined than diesel. And then the top-notch fuel, if you really want to get the best, is RP1, which is what SpaceX uses in its Falcon 9. So they use a very highly refined diesel. And basically what they're trying to do is get rid of the aromatics I was talking about, the ring chains which form a lot of the soot. So aviation fuel is more refined than diesel. I don't know if they've improved. I did read about this. I think it has improved since the 1970s. But the main thing that's improved is the quality of the engines. So the engines are much better now at burning fuel more cleanly than they were back in the 70s. If you remember in the 70s, if you ever watched a B-52 take off, it was like black smoke everywhere when that thing, instant darkness when that took off. Now, of course, the engines we're using are much, much cleaner, and very rarely do you see any black coming out of the back of a jet engine. So jet engine technology has just improved much, much more, I think, than the fuel has. So yeah, very, very clean burning now. And of course, all of the other emissions have come down as well. Nitrogen oxides have come down a long way as well. You can't reduce the amount of CO2 because that's just the result of burning fuel. The emissions from burning fuel is water and CO2 and a little bit of CO. You can't reduce that apart from making the engine more efficient, I suppose. So it's burning less than, because the actual engines are much more efficient. You look at a 737 when it started with those early JT8Ds, which looked like a cigar sitting underneath the 737. They burnt a lot of fuel. They were very thirsty. And then they went on to the CFM engines for the NG. Well, there was one before. There was the Classic, which had a fan, which was much more efficient. Then the NG had a bigger fan, which was even more efficient. And now they've gone to the Max, which has an even bigger fan. And it's even more efficient again. So between the original 737 engine and the new one on the Max, you probably find that fuel burn has gone down by 30% or something. It's a big difference anyway, between the early marks in the 60s and what they're producing now. So yeah, aircraft have become much more efficient.
Okay, my final question, I'm dropping way back to the start of your presentation when you're talking about the crazy, I don't know if it was over 100 million pounds they were going to spend on the hybrid planes. How far down the road did they get before they abandoned it? Did they actually try to stuff all that stuff into the fuselage and spend the money, or did they?
Yeah, they built it. Really it was a real aircraft. They actually built it. It all got in there, and then they found it would not work. I think they were doing ground testing of the engine, so they built, because they didn't have a lot of this equipment. They didn't have a electric motor that was big enough that would fit on an aircraft and deliver. I think they wanted 2.5 megawatts from that motor. So it was a gearbox electric motor together as a unit. All that had to be invented from new because it did not exist. This was done in connection with Siemens. I think Siemens made the electric motor. And the generator set as well, never been made before. This was I'm trying to think of how big it was. I think it was something like 5 megawatts. No, maybe a bit less than that. Anyway, whatever it was about 3-4 megawatts of generator gearbox to actually generate the electricity. Again, that was made by Siemens, never been done before. So they produced these 2 units, which was all fitted to the aircraft, which apparently sort of worked, but the whole thing itself did not work. They could not keep it cool. They could not, you got this jet engine running in the back of the aircraft. The whole thing became totally unfeasible. So they did ground testing of it, as far as I'm aware, running the engine and running the jet engine, but they never actually got airborne. So it was cancelled before it got airborne. I think they realized, because they're running this thing on the ground, they must know the fuel burns that are coming out of it. And they must know that, they've not made anything more efficient. They're probably burning more fuel with this system than the original engines were burning in the first place. So yes, it was cancelled before it got airborne. They spent 3 years on this. And they actually made the aircraft. I think the aircraft has now been scrapped because I don't think they wanted anyone to know what a failure it was. Yes, I don't think it exists anymore. I think it's gone.
But maybe they thought that there might be some sort of engineering miracle to make this all work. Maybe there was some hope when they started. Is that the deal? Or?
I don't see how that could happen, because I could see that this would be a failure from when it first started, because all of that equipment to make a hybrid work, you're adding so much weight to an engine, and an aircraft is so weight sensitive. There's no way you could ever make this work. So how they ever thought that it would work, because this is Rolls-Royce. I mean, it's not a company that doesn't know anything about engines. How they thought they could make this work, how the government technologists who are overseeing this grant application thought it could work, I've got no idea. Now, at the end of it, they were saying, "Oh yes, we've achieved all of these goals in this research. We've made this new generator set, which we've never had before. We've made this new engine, electric engine that we've never had before." Okay, all well and good, but when are you ever going to use those sets in any particular industry? I mean, I don't know. It's going to need a 4 megawatt generator. I don't know. So anyway, that's what they came out with at the end of this exercise, and they didn't spend all of the money. Apparently, Rolls-Royce, I think, only spent about 60% of it. So the government did recoup some of it back again. But the terms of the grant were that if none of the goals were met, they were supposed to pay the money back. And this was one of the contentions. I was saying that, Rolls-Royce should be paying this money back because they were taking this money away from, I was citing a whole load of light aircraft manufacturers who were making, parts for light aircraft, making light aircraft, instrumentation for aircraft, radios for aircraft, transponders and so on for light aircraft. All of these little companies who could have done so much with all of the money that they stole for this stupid project. None of those light aircraft companies got any money at all. It was all spaffed away on this major project, presumably, I think, because politicians like this. So this was announced by politicians. They went down to Farnborough and made this big presentation. So they get this lovely little golden halo, for making this, a politician coming up and saying, "Well, we've given this, grant money to this company, and they're going to make this small aircraft instrument." Well, there's no halo involved in that. But Rolls-Royce, they're going to make this. All aircraft are going to be, they're all going to be energy efficient and green and environmental. Well, they get lots of halos for that, and that's why these big projects are able to get all of this funding. And I think it's totally wrong. They should have much, much better people involved in the technical evaluation and adjudication of these grants, because this is our money and they're spaffing it away on stupid projects. I mean, America has done the same. This is happening all over the world. You remember that Solandra, was it?
Yes, Solandra.
Yeah, Solandra, where they spaffed away $500 million. And then there was the Crescent Dunes. You remember that one? They made this solar plant out in the desert somewhere, and it lasted for a year and closed. Then they opened it again, and it's just closed again. They spaffed away $1 billion on that. I mean, this is big money, and it's all your tax money that's just being thrown away, basically. So the oversight of these projects is just woeful. It really, I mean, this is why Elon Musk has been doing what he's been doing. You really needed an Elon Musk in there from day one to oversee these projects. The number of projects he's closed down, which were totally unnecessary and ridiculous and impossible. I think on the site at present, he's got a website, hasn't he, for his Doge. And I think at present they've saved $180 billion a year, which is not a bad saving. It's not as much as they wanted, but it's not a bad start. I think the biggest gain with it, that they're not talking about too much at present, but I think the biggest gain they're going to get out of Doge is frightening people into not doing this in the future. So all of these people who were pissing this dollars up against the wall for no good reason, in the future for the next 4 years, they're going to think, well, I'm going to get Doge breathing down my neck if I do this. So I'm going to be much more careful with the money that I'm spending. And so I think in the future years, you will have much less governmental spending because of that, even if their wrongdoing has not been discovered at present. So I think it'll make the government much more efficient, which is what it should be. You know, there's no point us earning all of this money if the government is just going to waste it. You know, shutting all of these departments down that were doing nothing. I mean, what was USAID doing? Nothing. What was the other one I thought was just crazy? USAP, USIP, the US International Peace, which is a government, and they went around there and go, what do you actually do with all this money? I mean, it was big money as well. It was something like $10 billion a year or something. And they had this wonderful glossy department in wherever it was, probably in Washington, wasn't it? This wonderful head office. And everyone's walking around, you know, all the Doge people walking around this office going, what do you actually do? Why is this office here? And so they just closed the whole thing down. And of course, nobody noticed anything different. Nothing has changed. All that money has been saved and can be spent on proper things, or even reducing your taxes, you know, heaven forbid. But anyway, yeah, they've just been closing down these departments, which I think is a jolly good idea, you know.
That is good, good news.
Yeah, absolutely.
Okay, I'm about ready to let you go. Any other points you want to make before we finish up here?
No, I think that's covered it. And yeah, if anyone has any questions, you know, when the video comes out, I shall try and join in and answer any questions in the comments below.
All right. Thank you very much, Ralph Ellis. We'll talk to you next time.
Great to be on board again. Thanks.